welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your class physics class 11th. That has been the class we have as your 20th class of the session. This has been the class as your for class 11th NCERT. We'll be starting with unit 3, which we had completed unit 1 here, that is a physical world. Second unit, that is units and measurement. Unit 3rd, which we had started, is your unit motion in a straight line. And in this we even though had discussed about the process that becomes to be clear, the limiting processes as well for the velocity time graph corresponding limiting values for the delta x by delta t at t equals to 4 seconds. These were all we have done in the last classes with the rectilinear motions and uniform graph, and as well as the constant graph and retardation. So now today we'll discuss about it, and we'll continue with the same, and we'll discuss about average velocity, average speed we had discussed. So we'll start with the question, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So the question we have is the question second of this particular unit. The position of an object moving along x-axis is given by x equals to a plus b t square, where a equals to 8.5 meter, b is equals to 2.5 meter second square, second inverse square, and t is measured in seconds. So what is the velocity at t equals to 0 second and t equals to 2.0 second? What is the average velocity between t equals to 2.0 second and t equals to 4.0 seconds here? So we go for the same. Second question. The position of an object moving along x-axis so in the same way we'll talk about it, and the further it will be the question we go for x-axis, that is given x is given by x equals to a plus b t square, is given by x equals to a plus b t square, where a equals to 8.5 meter, b equals to 2.5 meter secant inverse square, and t is measured in second. What is the velocity at t equals to 0 second and t equals to 2.0 second? What is the average velocity between t equals to 2.0 second and t equals to 4.0 second? Now we'll have to answer it out. So for that it will be in notation of differential calculus, that the velocity we have, which is v equals to dx by dt which is equals to d upon dt. X is your a plus bt square, to bt, which is 5 into 0 t second inverse. So at t equals to 0, here p equals to 0 meter second inverse, and at t equals to 2.0 second, v equals to 10 meter second inverse. So average velocity equals to x 4.0 is x 2.0 upon, which will be plus 16b minus a minus 4b upon 2.0, which will be equals to 6.0 into b. Okay, and that is equals to 6.0 into 2.5 equals to 15 meter second inverse here. That what we'll have to talk here, which is from this, the velocity is being, we know that during the period t equals to 10 second to 80 second, that the velocity is constant, and between the period t equals to 18 second to t equals to 20 second, it is uniformly decreasing, and during the period t equals to 0 seconds to t equals to 10 second, it is increasing. You have to note that for uniform motion, velocity is the same as the average velocity at all instants. Yeah, instantaneous speed, or simply the speed, is the magnitude of velocity. For example, a velocity of plus 24 meter second inverse and velocity of minus 24 meter second inverse both have an associated speeds of 24 meter second inverse. It should be noted that though average speed over a finite interval of time is greater or equals to the magnitude of the average velocity, instantaneous speed at an instant is equals to the magnitude of the instantaneous velocity at the instant. Here, why so? So we talk about for acceleration, where rate of the change of velocity with respect to time. So let's go for it. Acceleration. Here we go. In terms of acceleration, where that the velocity of an object in general that changes during its courses of motion. How to describe this change? Should it be described as the rate of change in velocity with distance or with time? This was a problem even in Galileo time. It was first thought that this change could be described by the rate of change of velocity with distance, but though his studies of motions of freely falling object and motion of object on an inclined plane, Galileo concluded that the rate of the change of velocity with time is a constant of motion for all objects in free fall. On the other hand, the change in velocity with distance is not constant. It decreases with the increased distance of fall, and this has led to the concept of acceleration as the rate of change of velocity with time. The average acceleration a over a time interval is defined as the change of velocity which has been divided the time interval. So here we go. Equals to v2 minus v1 upon t2 minus t1 which is delta v by delta t. Change in velocity upon change in time, where v1 and v2 and v1 are the instantaneous velocities or simply velocities at a time t2 and t1. It is the average change of velocity per unit time, where the SI unit of the acceleration is meter second square inverse square, and a plot of the velocity that versus time by the average acceleration in the slope of a straight line that connecting the 2 points corresponding to v2 and t2 and v1 and t1. So the average acceleration of the velocity time graph for different time intervals, and that is 0 second, 10 second, 10 second to 18 second, 18 second to 20 second that we have here. We'll plot those, and accordingly we will be plotting it out. Just we solve this in a way. So we just find it out first. 0 second to 10 second, it will be a bar equals to 24 minus 0 upon 10 minus 0 seconds, so 2.4 meter second square. For 10 second to 18 second, it will be 24 minus 24 meter second inverse, which is 18 minus 10 second, equals to 0 meter second inverse. 18 second to 20 second, bar equals to 0 minus 24 meter second inverse upon 20 minus 18 second, equals to minus 12 meter seconds square. So now we plot this diagram here, and that will find it out as well. So here we go. It will be 4.8, 2.4, then 0, minus 2.4, minus 4.8, minus 7.2, minus 9.0, and then minus 12.0. So from 0 it will be the line drawn. We'll plot 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and 22 that we have. So here for the same it will be here. Okay, this is the acceleration as a function of the time for motion that has been representing. So for that it will be plotted from 0 to 10. It will be this, and here this is how it goes. So here for instantaneous acceleration, that has been defined in the same way as the instantaneous velocity. So for that it will be a equals to limit delta t equals to tends to 0, where delta v by delta t equals to dv by dt. Now here that the acceleration at an instant is the slope of tangent to the vt curve at that instant. For the vt curve we can obtain the acceleration at every instant of time, and that the resulting a and t curve is being that we had shown, and you can see as well. So accordingly we will be going that acceleration is non-uniform over the period. It's 0 second to 10 second, and it is 0 between 10 second and 18 second, and is constant with value minus 12 meter second inverse square between 18 second and 20 second. When the acceleration is uniform, obviously it equals to the average acceleration over that period. Since velocity is a quantity having both magnitude and direction, and a change in velocity may involve either or both these factors, acceleration therefore may result from the change in speed, which is magnitude, and a change in directions, or a change in both, like velocity, acceleration, that can also be positive, negative, or zero. Position time graph for motion with positive, negative, and zero acceleration are will be discussed here. And on the same way, that the graph that curves upward for positive acceleration, downward for negative acceleration, and it is the straight line for the zero acceleration. As an exercise, we will be doing those here, and we even though had done. So for the same, it will be on the three cases. And although the acceleration that can vary with time, our study in this chapter will be restricted to the motion with constant acceleration. So in this case, the average acceleration is equals to the constant value of acceleration during the interval. And if the velocity of an object v naught at t equals to 0 and v at time t, so then we will be having a bar here. So then it will be a bar equals to v minus v naught upon t minus 0, or v equals to v naught plus at. So for that, position time graph for the motion with positive acceleration, it will be t 0 x tends to be, and this is your positive a. So here for this is t, this is x, negative a. Then we have another one, so that we have, this is the position time graph for motion with positive acceleration, negative acceleration, and a zero acceleration. On the same way, you have to let us see how velocity time graph look like for some simple cases. And velocity time graph for the motion with constant acceleration, that for the following cases we will be drawing. And in that, an object is moving in a positive direction with positive acceleration. For example, the motion of the car in between t equals to 0 second to t equals to 10 second. So for that, it will be like this. This is a graph. Here it will be 0. This is v. So it here for v naught to t. This is v naught, and this is t, and this is vt. So here full acceleration is being. Now for the second case, we talk about it, and that what we'll have here is being as follows. This is t, v0, and v naught. So for that. This is V0. This is the retardation one, and that what we'll discuss. As an object is moving in a positive direction with a negative acceleration, for example the motion of a car, between t equals to 18 second to and 20 second as well. So we'll go for the third one, which we'll be having here as well, and that will be drawing for you so that to be cleared out. That has been in the form, this is 0 t minus V0 this is your minus b as well. So here for this we talk about it that an object is moving in negative direction with a negative acceleration, for example that the motion of a car moving from 0 in a negative x direction with increasing speed. Now we talk about for the next one, which we have this is t2. This is at t1 v0 and this is minus v. So here for the same, at an object that is moving in a positive direction till the time t1 and then turns back with the same negative acceleration, for example the motion of a car of a point P to Q, and that till the time t1 that decreases the speed and turning back to moving the same negative acceleration as well. Now we will be going for the interesting feature that we'll discuss here, where an interesting features of a velocity time graph for any moving object is the area under the curve that represents the displacement over a given time interval, where a general proof of the statement require use of calculus. We can however see that it is true for the simple case of an object moving with constant velocity u and its velocity time graph that being shown here. So we'll be showing that. So for the same, this is the graph that has been the velocity time graph for the motion with a constant acceleration, where that the first graph is your motion in is positive direction and positive acceleration. The second is motion in a positive direction with negative acceleration. The third one is the motion in a negative direction with negative acceleration. And the fourth one is the motion of an object with negative acceleration that changes the direction at time t1 between times 0 to t1, and it moves to the positive x directions, and between t1 and t2 it moves to the opposite direction as well. So on your same way we talk about for the area under the VT curve that equals displacement of an object over a given time interval. So that we have here for the same t here capital T, which will be extended. This has been 0 u and this is b term graph. So here it is mean 0. This is area under the VT curve that equals to displacement of the object over a given a time interval. This is an area that we are talking about. And for the same it will be the statement requires us to calculus. We can however see that the true of the simple cases of an object moving with constant velocity u and its velocity time graph is being shown that I had represented here. On the same way, the VT curve is a straight line parallel to the time axis in the area under its between t equals to 0 and t equals to t in the area of the rectangle of height u and the base t, where therefore that area equals to u into t, which is ut, and which is displacement in this time interval. And how come in the case and area is equals to the distance as well. And note that the dimensions of the quantity that can be the two coordinate axes, and you will be arrived to the answer as well. Note that the xt and vt and at graphs that shown in several figures in that chapter have a sharp kinds at some point, and implying that the functions are not differentiable of these points. In any realistic situation, that the function is a differentiate at all the points in the graphs with the soup. And what this means physically is that the acceleration and the velocity that cannot change the value abruptly at an instant, and changes are also always a continuous. Now we'll be ending it up here, and we'll be continuing the next class in the sessions as well. So before ending it up, we had done your chemistry part 1 for class 11. Part 2 we are dealing physics part 1, which we are dealing here. And other than that, we had done your reasoning, which is verbal reasoning and non-verbal reasoning. We even though had done your that is your in the same way we are dealing with the CBNST that we have. So in terms of CPNST, we had done your DPMS, that is database management system. We are dealing with the ER diagram. And we had done your quantitative aptitude we are dealing with, where in that we had started with arithmetical ability. In that we had done your 16 topics, and we'll be continuing with the 17th topic. Last, that what we talk about the physics. Here we had done your chapter 1, that is your physical world, where we had completed your what is physics, scope and excitement of physics, technology and society, fundamental forces in nature, nature of physical law. Chapter 2, which we had completed the units and measurement, is your introduction, the international system of units, measurements of length, measurements of mass, measurement of time, accuracy, precision and instruments, and errors in measurement, significant figures, dimensions of physical quantities, dimension formulas and the dimensional equation, dimension analysis and its application. The unit third is your motion in a straight line, where we had completed your introduction, position, path length and displacement, average velocity and average speed, instantaneous velocity and a speed, acceleration we are done, and kinematics equation for the uniformly accelerated motion we have to do, and the relative velocity we have to do. After that, we'll complete your chapter 4, which is motion in a plane. That what we have to cover up here is your introduction, scalars and vector, multiplications of vectors by the real number, additions and subtraction of vector, graphical method, resolutions of vector as well, vector addition, analytical method, motion in a plane with a constant acceleration, relative velocity in the 2-dimension, projectile motion, uniform circular motion. Unit 5th is your laws of motion, which is we will discuss about the introduction, Aristotle fallacy, the laws of inertia, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conservations of momentum, equilibrium of particles, common forces in mechanics, circular motion, solving problems in mechanics. Unit 6 is your work, energy, power, where we have to cover up the introduction, notion of work and the kinetic energy, the work energy theorem, work, kinetic energy, work done by variable forces, the work energy theorem for the variable forces, the concept of potential energy, the conservation of mechanical energy, potential of a spong, various forms of energy, the laws of conservation of energy, power and collation. Unit 7 is your system of particles in rotational motion. Unit 8 is your gravitation. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.